Lesson 22 is graphing a factored quadratic. So before we get into the actual graphing part of it, we're just going to talk about what a quadratic graph actually looks like. So in 22.1, we introduced the concept of a parabola. So when quadratic equations are graphed, the shape it makes is called a parabola, which is kind of like a U-shaped graph. So we're going to skip the little recall section for now. I'll go back to that. But if we look at these two graphs here, one of them is kind of like a nice smooth curve shape, kind of like a U. Not an exact U, but like kind of like a U. It opens upward. And then the second graph is pretty much the same shape, it's just opening down. So these are examples of parabolas. I know like a U always opens up, but it can go either way for a parabola. It's just kind of important that it's like that nice smooth curve. There is kind of symmetry across it. We'll talk about that more in the next section. But before we move on to kind of figuring out what makes the parabola open up versus open down, I think the best way to make this kind of ingrained into your memory and help you remember what a parabola actually is the SpongeBob imagination meme. Because imagination creates a little rainbow, and that's what a parabola is. It's kind of like that nice smooth curve shape, whether it opens up or opens down. So now that we kind of know what the shape looks like, we can talk about what causes it to open up or open down. Before we do that, we'll review what standard form of a quadratic is. So that's up here. So standard form of a quadratic is y equals ax squared plus bx plus c, and then a, b, and c, those are like coefficients and constant term. Those variables are important. So in this case, a is the coefficient of x squared. Not really in this case, like this is always standard form of a quadratic, so ignore that in this case. But a is always the coefficient of x squared, b is always the coefficient of x, and then c is always what's called the constant term, the one that doesn't have a variable. And all three of those values in the actual function, whatever numbers that we have there for a, b, and c, they all kind of like create different parts of the graph, or they have a different impact on the graph, but only one of those letters impacts whether the graph opens up or opens down, and it's a. So if we look at the two actual rules for our graph, the first one is y equals x squared minus 4x plus 1. The second one is y equals negative 3x squared minus 18x minus 23. So now if we look at a in both of those, remember a is the coefficient of the x squared term. So in the first one, there's no number there, so it would mean that a is 1. And then in the second one, the coefficient of x squared is negative 3. So first graph, a is 1. Second one, a is negative 3. The numbers don't matter so much as the positive and negative. So you'll notice when a was positive 1, the graph opened up. Think of it as like increasing. And then when a was negative 3, the graph opened downward. So it's kind of like decreasing. So whenever a is positive, any positive number, it could be like positive 0.1 or like positive 1,000,000, the graph will open upward. So when a is positive, I did not type the like is in there, so excuse me. But when a is positive, the graph opens up. And then when a is negative, the graph opens down. So this concept is something that will continue to pop up throughout the class. So this is definitely something that's really important to put. When a is, there should be an is in there, sorry guys. When a is positive, the graph opens up. When a is negative, the graph should open down. No matter what the actual number is, we just look at positive versus negative when we're trying to decide if it goes up or down. Okay, so the next section right here, every parabola has a vertex. The vertex is the point where the graph changes direction. So you'll notice like on each of these graphs, there is a point where it changes direction. So like right here, it goes from going downward to going upward. And then right here, it goes from going upward to going downward, if you follow the graph from left to right. So that kind of point where it changes, that's called the vertex. That's another really important word to know. So our vertex is right here. And right here. And then the second thing for this section, every vertex is either a maximum or a minimum. So no matter what, if you look at a parabola, you look at the vertex and it's either a maximum or a minimum. And the way that you determine is you look at, okay, is this the lowest point of the graph? If that's the case, then it's a minimum. If it's the highest point, then it's a maximum. So if I look at this first graph, the one on the left right here, that point where the vertex is, that's the lowest point on the graph. There is no point lower than that one, and the graph is going to continue to go up from there. So since that's the lowest point, it's also a minimum. And then on the second graph, if we look at the vertex right here, that's the highest point on the graph because from that vertex right here, the graph just goes down from there and it'll continue to go down forever. So since that's the highest point, that's a maximum. Okay, so every vertex is either a minimum or a maximum. It just depends on whether the graph is opening up or opening down. Okay, so for example 1, determine if the parabola opens up or down and if it has a maximum or a minimum. So to determine both of these, we only need to look at the a value. So remember that a is always the coefficient of x squared. I'm going to rewrite the formula right here. So ax squared plus bx plus c, that is standard form. For this problem, we have to look at a. That's the only value that we need. Okay, so for example 1a, y equals 6x squared minus 9x plus 1. The only thing I care about when I'm determining if the graph opens up or down is the coefficient of x squared, which is 6. Okay, once I identify that number, I say, is it positive or is it negative? So 6 is positive. So right here, it's really important to have when a is positive, the graph opens up. So opens up. And then especially if you don't have a graph in front of you, it's kind of helpful just to draw like a little baby sketch. So like if the graph opens up, that means it looks like this. Something like that, at least. And then when I'm determining whether there's a minimum or a maximum, I can use that little sketch to see like, okay, is the vertex the smallest point, the lowest point, or is it the highest point? So if I look at the vertex now, it's right here. It's the point where it changes direction. And that's like the lowest point, the very, very bottom. There is no top because the graph is going up forever, so it's like infinity. But that vertex is the lowest point, so that would be a minimum. Okay, so when you see like a minimum, or when you see a lowest point, that means that it's a minimum. It's like a minimum value. And then if we look at b, so y equals negative 3x squared plus 10, notice this looks like a little bit different than standard form because it doesn't have a bx term in the middle. That's okay, it doesn't have to, it just has to have the x squared, that's the only thing. So a is the coefficient of x squared, so in this case it's negative 3. So once we identify, we're like, okay, is it positive or negative? Negative 3 is definitely negative, so when a is negative, the graph opens down. And then if it opens down, I can draw myself like a little sketch of a U shape that's opening down, kind of like my imagination rainbow. And then I can see, okay, where'd my vertex be? Like that's where it changes direction. That's that little circled blue dot. And then I look at that point and I'm like, is that the top or the bottom of my graph? And it's the top because everything is going down from there. So if it's the top or like the highest point, that would be a maximum. So if you see that your graph has like a highest point on it, that would mean that it's a maximum. Example 2 is graph a quadratic using a table. So the quadratic is y equals 2x squared minus 4x plus 3. And then just a heads up, in your workbooks, the tables that they have are pretty big. Typically, you need at most only 5 points to graph a quadratic. So that's why my table has just the 5x values. This process does kind of take a while. You'll see it's a lot of like kind of repeating the same steps, so this problem will take a little bit longer, but I think it's really important to get a good feel for the process the first time through. So our table has x values -1 up to 3. To find the y value that goes on the other side of the table, we need to take each of our x values and put them into the function. So it's y equals 2x squared minus 4x plus 3. I'm going to use the first x first, so x equals -1. And then this does take up a decent amount of space on a paper, so make sure you have plenty of room. But x equals -1, we'll do that first, and we'll put that in for the x's in the equation. So y equals 2 times -1 for x, and then squared, minus 4 times -1, and then plus 3. And then now we simplify, so think like order of operations, it's PEMDAS or GEMS. So like parentheses, exponents, multiplication, division, addition or subtraction. So in this case, we have the exponents first. So we'll take that -1 and raise it to the second power. So 2, and then -1 to the second power is -1 times -1. So that turns into a +1. Minus 4 times -1, just going to bring that down, and then plus 3. And then now I have a couple of multiplications. So I'm going to go ahead and multiply them both. They don't really interfere with each other, so that's fine. So it'll be y equals 2 times 1 is 2. And then this is like a -4 times a -1, so that would turn into a +4 and then plus 3. And then now I can just add from left to right. So 2 plus 4 plus 3, 2 plus 4 is 6, and then plus 3 would bring me up to 9. So I have y equals 9. That's the y value that goes with x equals -1. Okay, so now we just have to repeat that same process with the other x values on the table. It will be pretty much the same exact process, so if you can work quicker than me, you're more than welcome to. And then can kind of check the answer at the end and kind of speed it up a little bit. Okay, so the next x value is x equals -1, or sorry, x equals 0. I don't know why I said -1, but x equals 0. I'm going to try to kind of box these off to keep them separate. It does, like I said, takes up a ton of space on the room. Okay, and then x equals 0. So 0 is going in for x this time. So it'll be y equals 2, and then parentheses 0 squared, and then minus 4 times 0, and then plus 3. And then same, the thing that's kind of nice about like, even though it's tedious, is that the steps are the same each time once you go to simplify. So like first in the like kind of first part that we did exponents first, and then we multiplied, and then we added. So we're going to keep that same order. Exponents first. So y equals, bring down the 2. 0 squared means 0 times 0, so that's still 0. Minus 4 times 0 plus 3. And then now I can go ahead and I can multiply. So 2 times 0 is 0, and 4 times 0 is 0. So those are both just like 0. So they're nothing. So that leaves me with just the 3. So y equals 3. So that's kind of nice, like putting like 0 in for x in standard form is it always cancels out the x term. So it always just leaves you with whatever the constant is. In this case, it was 3. So it's kind of a shortcut you could take if you remember that. So y equals 3. That goes next to the 0 on the table. And then the next x value is going to be x equals 1. So x equals 1. And then as you get like more comfortable with these, you will probably be able to work through it more quickly as well. Not that you have to, but you could necessarily as you start to get more practice with them. So x equals 1, and then y equals 2 times 1 squared, since 1 is going in for x, and then minus 4 times 1. and then plus 3, and then y equals, so same order, we're going to square the 1 first. So 2 times 1 squared means 1 times 1, which is 1. And then we bring down the rest, 4 times 1 plus 3. And then now I can multiply 2 times 1. So y equals 2 times 1 is 2, minus 4 times 1, so minus 4, and then plus 3. And then now for addition and subtraction, a lot of people want to add first. It does come first in PEMDAS, but between addition and subtraction, there's no order. So you just go left to right. So we would do 2 minus 4 is negative 2, and then plus 3 is 1. So y equals 1. So if you just have addition and subtraction left, you always just go left to right. And then y equals 1 would go in our next spot in the table. And then our next x value is going to be 2. So x equals 2. So same process, put 2 in for x into the function. So it'll be 2 times 2 squared, and then minus 4 times 2, and then plus 3, and then simplify exponents first. So y equals, bring down the first 2, and then 2 squared means 2 times 2, so that's 4, minus 4 times 2 plus 3, and then now we can multiply. 2 times 4 is 8, so I have y equals 8, minus 4 times 2, that's also 8, so minus 8, and then plus 3. And then now I just have addition and subtraction left, so I'm going to go left to right. So 8 minus 8 is 0, and then plus 3 would be 3. So y equals 3. That goes in my next spot in my table next to the x equals 2. And then now I have my last x value. Okay, so on a lot of the problems you have like, there's only like, okay, so a lot of the problems have like kind of tables filled in and you'll match it with the graph, or you'll match it like with the correct like y values that go with it. And if that's the case, you only need to do this so many times so that you know the correct pairing. So like once you kind of identify like it has to match up with this one, you don't have to kind of continue with this process. This would just be if you were graphing something from scratch. So it is good to know, but you won't have to do this for every problem. So the next one is going to be x equals 3. It's our last x value. So same process, y equals 2 times 3 squared, and then minus 4 times 3, and then plus 3 at the end. So exponents first, so y equals 2 times 3 squared is 9, and then because it's 3 times 3, and then minus 4 times 3, and then plus 3, and then now we can multiply. So 2 times 9 is 18, minus 4 times 3, so minus 12, and then plus 3. And then now 18, or we can just go left to right, we can do all in one step, but 18 minus 12 is 6, plus 3 is 9. So y equals 9. Okay, so y equals 9 goes on our last spot on our table. And then now we have our points essentially. I know they're not written as points, but that's actually what a table is. It's just a different way of organizing points. So you can go ahead and write them in parentheses if it's helpful for you. So like for example, and this is totally optional, but if I wanted to write like the first line as a point, x would go first, so it'd be negative 1, 9. The second one would be 0, 3. The third one would be 1, 1. The fourth one, 2, 3. And then the fifth one, 3, 9. Because remember, points are organized as x first, and then a comma, and then y. Okay, so we're ready to graph them. So I'll start with the, let's see, I'm going to grab a different color so it's a little bit easier to see on the graph. And then the first point, negative 1, 9, I would go left 1, and then I would go down, or up 9, excuse me. So left 1 and then up 9. So it would bring me right here. And then the Second point, 0, 3. If x is 0, I don't go left or right at all. I just go up 3, so that would land me right there. And then the third point is 1, 1, so that means that I go right 1, and then I also go up 1. And then the fourth point is 2, 3, so I'm going right 2, up 3. And then 3, 9, I would go right 3 and then up 9. Okay, so now when we go to like actually connect the points, not that this matters a whole lot with like kind of online school, but remember like when you're connecting your points that you should like draw your curve like it's a nice smooth U shape. So don't draw it like this where it's like a V. Try your best to like make it like kind of nice and like curved through the middle. So I'm really bad at drawing these, but something like that if you can. And again, like the points are the important part. It's just kind of good to know that, you know, it's a nice like smooth curve. It's not really like a V shape. Okay, and then that's how we graph using a table. So the next section is going to combine 22.2 and 22.3, and it's talking about parabola symmetry and then graphing quadratics that are in factored form. So this like kind of image obviously has a bunch of stuff blurred out. It's just new terms. So this has a lot of important stuff. So I would draw this and kind of keep it somewhere that you can refer back to. So parabolas, quadratics, they have like symmetry, and so they have this thing called the line of symmetry, and that's something that cuts the graph in half, and it's a vertical line that goes through the vertex. So if we look at this image, the vertex is, it's covered right now, but it's right here. That's the point where it changes direction. And then we have like this kind of imaginary line. It's not actually a part of the graph. We have this imaginary line that's called the line of symmetry. So I'm going to uncover it now. Usually we draw it with like a dotted line, so it's not actually part of the graph. And then it's called the line of symmetry. It's basically like the middle of a butterfly. So like, you know, like the butterfly spine, it goes like its wings are symmetric. This is like kind of the perfect middle point. And that's what's kind of labeled here, is that this point right here is perfectly in between the parabola, and any point on the line of symmetry would be perfectly in the middle of the parabola. So it's the halfway point. What I mean by that is like, you know, this is at x equals 3, like that's the value. So this is from like 3 to 9, which is 6, sorry. And then this way is like 3 to -3, which is also 6. So it's 6 in both directions, and that would be the case for any point that I put on like the line of symmetry. So like this is 3, this is 3, this is 2, this is 2, and so on. Okay, another like phrase that you'll see sometimes instead of line of symmetry is axis of symmetry. So I'm just going to apologize ahead of time if I accidentally call it an axis of symmetry. It's the same meaning. Okay, and then the last two, or not two, but like one kind of vocab word that's really important to know here is zeros. So, I mean, it's not like necessarily just the number 0, it's where the function or the graph crosses the x-axis. So you can see that green line is the x-axis, and then those 2 points where it's crossing, those are considered a 0. And that's what they're called because if you think about this point right here, this is the point -3, 0. And then this is the point 9, 0. So it's the value that makes y equals 0. Or it's the point that makes the y coordinate 0 is called a 0. So you'll see that come up like throughout the rest of this class and then throughout Algebra 2 as well. Okay, so definitely have this, save it. If you didn't write it, take a screenshot of it and have it somewhere where you could refer back to when you're like, okay, what's a 0? Just so you can find it. Okay, so now graphing factored form, the like formula or equation for factored form. This is, both of these are really important and need to be somewhere where you can access them. Or the factored form equation is y equals a parentheses or times x minus r times x minus s. Also, I didn't type this, but this is an important note. R and S are zeros, or where they cross the x-axis or x-intercepts. So leave a note for yourself. R and S are zeros, and that means x-intercepts. And we usually shorten intercepts by just like INT. It's where it crosses the x-axis. So like 3 or -3 and 9, those are x-intercepts because those are the numbers where it's crossing the x-axis. We'll talk about that more in the actual examples. And then the formula for the line of symmetry is x equals r plus s over 2. Sometimes you'll need that and sometimes you won't. It just kind of depends on the problem. Okay, so example 1, I'm going to go ahead and just rewrite the equation for factored form up here just so I don't have to make sure like to keep the other one in frame. So a and then times x minus r times x minus s. So the first thing that we need to do for these problems is example 1 is y equals x minus 3 times x plus 1. We got to figure out what r and s are. Those are critical. So honestly, order here doesn't matter. You can say r is the first parentheses, s is the second, but that part doesn't really make a difference. What's really important to pay attention to here is that this is x minus r and this is x minus s. That's a part of the formula. And what that means is that r and s are kind of the opposite of what they look like. So if I compare like up here, this to x minus r, well, x matches perfectly, minus matches perfectly, r must just be +3, not -3. So we'll say r is 3. And then for the second part, so for x minus s, you're like, okay, so the x matches, but where is the minus? Like, why isn't there a minus there? And it's because if I were to rework this x plus 1 with a minus, so x minus, the s value that turns that s minus to an x plus is a -1. Because, you know, double negative, that turns to plus. So x minus -1 would turn into an x plus 1, and that's exactly what it does here. So that would mean that, so x matches up perfectly, the minus matches up perfectly now, and then so s must just be -1. Okay, you don't have to like write it all out like that the entire time and say like this matches here, this matches here. It was just kind of helpful or important to see the first time. So s equals -1. The biggest thing is just recognizing that because in the formula it has the minuses, so right here and right here, these are the opposites. So like this was x minus 3, it turned into a r equals +3. This was an x plus 1, it turned into an s equals -1. Okay, so r and s are x-intercepts. So those are the first 2 points on our graph. So the x-axis is the horizontal one. So this is the x, this is the y. So I have a x-intercept at 3 and an x-intercept at -1. So I'm just going to put those points on the graph. So 3 on the x-axis is right here, -1 is right here. Okay, so the thing that we know about parabolas is that they're symmetric. So since we have these 2 points that are like in line with each other, the axis of symmetry has to be like perfectly in the middle of them. So that's why, line of symmetry, it has to be perfectly in the middle of them. So you don't always have to use the formula. I want to kind of show you what I mean. Is that in between these 2 points, there's a distance of 4 units. So the halfway point is right here. So I could draw, like if I wanted to, I could draw the axis of symmetry on there. Look like that. And then I could figure out what the equation of that line is. So I keep saying axis of symmetry, I'm sorry. The line of symmetry. But for the line of symmetry, I'm going to shorten symmetry to SYMM. The line of symmetry, the equation, is always starts with x equals, and it's going to be the number where it crosses the x-axis. So if we look to see where this crosses the x-axis, it's at 1. So in this case, it would be x equals 1. And then now let's just try it. Like, let's use the formula and see if that's like the same exact thing that I would get using the formula. Okay, so and when I say the formula for line of symmetry, I'm talking about this one up here. So let's try it. It's supposed to be x equals r, so 3. That's like the first part up here. And then plus s, so plus -1 over 2. And then now I can add, okay, 3 plus -1, that's 2. And then 2 over 2 is 2 divided by 2, that's 1. So I ended up getting like the same exact answer. So I would say it's only really necessary to use the formula if you can't tell the exact halfway point on the graph, which it does happen sometimes. But on this one, it was easy enough to tell what is halfway between -1 and 3. It was +1. Okay. And then the last thing that we need to do is we need to find the vertex of the graph. So we know the vertex of the graph is going to be somewhere on this axis of symmetry because it always falls on the axis of symmetry because it's in the middle. So like if I go back up to this graphic, you can see that the vertex is on that axis of symmetry. That's always the case. So that means that we know that the vertex is on the line x equals 1. So to just find like the y value for the vertex, I just have to put x equals 1 into the equation. So for the vertex, you put, I'm going to shorten line of symmetry into LOS into the equation. So the line of symmetry is x equals 1. So the equation itself is y equals x minus 3 times x plus 1. I'm going to take that 1 and put it in for both x's. So it would be y equals 1 minus 3 times 1 plus 1. And then y equals, we simplify each parentheses separately. So 1 minus 3 is -2. 1 plus 1 is positive 2. And then now I can multiply those two together. So -2 times 2 is -4. So we put in x equals 1 and we got out a y equals -4. That's going to be our vertex. So the vertex, write it up here, is going to be 1, -4. So we got to put that point on the graph. So 1 would go right 1 and then down 4. Your graph should always be on the axis of symmetry. And then now we can just connect our vertex through the intercepts and that'll create our graph. So we'll make sure it's a U shape. And now we have a parabola that represents our equation. So example 2 is another similar problem. I get this video has been kind of on the long side. These problems take a while. So if you feel like you got enough out of that first example, you're welcome to stop the video, or if you want to kind of take a break and come back and watch the other example later, totally fine. So example 2, y equals 1/2 times x plus 6 times x minus 2. So I'm gonna just go ahead and drag this formula over, and then that way we can kind of ignore what's going on, all the like clutter from example 1. Okay, so the first step is we have to figure out what R and S are, because those are gonna be our first 2 points. Okay, so R, it really doesn't matter which one it goes first. It ends up being the same graph. So we'll say R is what's in the first parentheses. However, because we know there's that minus inside the parenthesis or inside the original formula, this is really like an x minus -6. And so that's what turns it into an x plus 6, because that first minus is already there. So that would mean that R is -6. And then for S, we can see like, okay, this X matches this X, the minus matches this minus, so that must mean that S equals just +2. So that goes back to like, it's kind of like just the opposite of what it looks like it should be. So if you have, in this case, we had an X plus 6, it ended up being -6. Here we had an X minus 2, S was +2. So R and S are our first 2 points. So we go to the x-axis, that's the horizontal one, and we put a point at -6 on the x-axis, so right here, and then also at 2, so right here. And then honestly, if you can like look at the graph and count like what would be the axis of symmetry, or sorry, the line, I know I'm going to say it a lot, the line of symmetry, like what's the halfway point between those two, you should do that. So the line of symmetry is, the formula for it is R plus S divided by 2, but it's also the halfway point. That's not how you spell halfway. Halfway between R and S. Okay, so if we look at R and S, like the distance between them, it's like 1, 2, 3, 4, 5, 6, 7, 8. Their distance is 8 units apart, and then so the halfway point would be 1, 2, 3, 4, because 4 is half of 8. So it'd be at -2. So it's helpful to draw like what the axis of symmetry would be. I'm going to go ahead and add it to my graph, but it's going to cross through at that -2 on the x-axis. So right here. Sorry. I went rogue. Okay, so it's right there. Double check always that it is like perfectly halfway. Like this is 1, 2, 3, 4 units, and then this is 1, 2, 3, 4 units as well. It should always be the halfway point. And then now, sometimes you'll be asked, like, what is the equation of the axis of symmetry? So you do have to be able to write the equation. So I said axis again. So line of symmetry, the equation is always x equals. And then it's the number where it crosses the x-axis. So in this case, it crosses the x-axis at -2. The x equals part is important. That's what makes it a vertical line, like that pink dotted line. Okay, and if you ever can't see the halfway point, or if you are having a difficult time writing the equation for the line of symmetry, then I would definitely recommend using this formula because it has the x equals in it, and then you can put R and S in there and simplify, and you'll get that x equals -2. Okay, so I'm going to go back to example 1 really quick. So we got to repeat this process to figure out what our vertex is. So to find the vertex, we have to put the line of symmetry into the equation. So the line of symmetry in this case is x equals -2, the value we found. So I'm going to copy down the equation really quick. It's y equals 1/2 times x plus 6 times x minus 2. And then I'm going to take that x equals -2, or just the -2, and put that in for both of the x's. So that'll be like y equals 1/2 times -2 plus 6 times -2 minus 2. And then now we simplify each parentheses first. I want you to wait to the end to multiply by the 1/2. So it'll be y equals, I'm going to leave the 1/2 in front. And then I'm going to simplify both parentheses. So -2 plus 6 is 4. And then -2 minus 2 is -4. And then in this case, it honestly doesn't matter which way or which order you multiply the 1/2, the 4, and the -4, because they're all being multiplied. So it may be easier, just kind of depends on preference, to multiply the 4's together first and then multiply the 1/2 in after. It's up to you. So I'm going to just rewrite y equals 1/2 and multiply the 4 times -4 first. So 4 times -4 is -16. And the reason that we're able to do that is because if they're all being multiplied, we won't really have to follow order of operations because multiplication is commutative, meaning that we can reorder it if we want to. And then 1/2 times 16. So anytime, like literally anytime, you multiply a number by 1/2, it's the same thing as dividing it by 2. So if you're like, okay, what is 16 or negative 16 divided by 2? It's negative 8. So we end up with y equals negative 8. And we put in x equals negative 2. That was from our axis of symmetry. So we put x equals negative 2 and x equals negative 8 together and get negative 2, negative 8 for our vertex. So now we just need to graph that point. So negative 2, I'm going to go left 2, and then I'm going to go down 8 to get to negative 8. And then I'm going to take that vertex and I'm going to connect it through my intercepts. And then that's it. That's the whole graph. Okay? So biggest thing is just knowing that first I'm going to kind of label these steps in case that makes it a little bit easier for like you to refer back to. So first you find R and S, and remember that they're the opposite of what they kind of look like. And then second, you find the line of symmetry, and you can find that two ways. You can find it by looking at the graph and finding the like kind of middle point between the two intercepts that you put on the graph. Or you can use the line of symmetry formula. It's totally up to you. And then the third step is this whole kind of mix of things right here. So third step is to put the line of symmetry in the equation. Whatever you get for the line of symmetry, put it in, and that'll give you the y value from your vertex. And then you kind of just put the x from the line of symmetry and the y from your vertex together, and that creates the whole point.